Sup, nerds? So today's the spring equinox, and you might be wondering what that is. So I figured I'd make a little video just to explain it. Here we have a little animation of the sun and the earth, and as hopefully most of y'all know, the earth revolves around the sun, and also hopefully you know that the earth is a little bit tilted, which leads to seasons and different amount of sunlight during those seasons. So the way it's pictured here, it's summer for the northern hemisphere, and so the colors represent how much light the portion of the earth is getting. So here the northern hemisphere is getting more light than the southern, but as the earth rotates, say goes towards the northern hemisphere's fall, you could see the yellow becomes more balanced around the black line. The black line represents the equator. And then as time goes on, there's more light going to the southern hemisphere below the equator. So it's summer for the southern hemisphere and winter for the northern hemisphere. The winter solstice is when this is at an extreme, and the sun is as south as it gets, reaching all the way down to the Tropic of Capricorn. And then starts to move back north until we reach the spring equinox, which is today, where both the northern and southern hemispheres receive the same amount of light. And this pattern continues. Northern hemisphere gets more for the northern hemisphere summer, the summer solstice, and then fall equinox, and so on and so forth. A natural question to ask is, how does Earth's tilt and revolution affect how we see the sun go through the sky? So let's take a look at different latitudes at different times of the years and different times of the day. So start off at the equator during one of the equinoxes during sunrise. So this side is going to be east, this side is west, the bottom is south, and the top is north. So the sun passes directly overhead during the equinoxes at the equator. And if we go, say, towards the northern hemisphere's summer solstice, then it's passing a little bit further north. It's still close to being overhead, but it would be directly overhead for, say, someone at the Tropic of Cancer. Meanwhile, on the other end, if we went to the southern hemisphere summer solstice, then the sun would be passing a little bit further to the south. Let's consider maybe a different latitude. So say we went to something in the 40s, so like, say, New York. Then during the equinox, the sun is still rising in the east and setting in the west, but it's doing it at an angle. And if we go towards the summer, the path gets longer. That's why the days are longer, but it never gets directly overhead. And the higher your latitude goes, say we went all the way to the North Pole, the longer the summer days become. So this is summer in the northern hemisphere at the North Pole. And as you can see, all day long, there's sunlight. So the sun just revolves a little bit above the horizon for months at a time. But if you go towards the northern hemisphere's winter, the sun is revolving just below the horizon. So at the North Pole, you'll have months and months of darkness, and then months of light. And then the opposite happens at the southern hemisphere. So this is the summer, this is the South Pole during the South Pole's summer. It's daylight all day long, but then during the northern hemisphere summer, it's darkness all year long, all day long. This agrees with what you would expect by looking at the Earth revolving around the sun and the tilt. So during the northern hemisphere's winter, the North Pole is facing away from the sun and doesn't receive any sunlight, even as it spins. The South Pole, even as it spins and goes away from the sun, it'll still be receiving light. But if we let time pass and we go to, say, the summer solstice for the northern hemisphere, then the North Pole will be receiving light all day long, and the South Pole will be in darkness all day long. One more thing to think about is, what if the Earth was tilted a little bit more or a little bit less? So if we had less of a tilt, and some planets in our solar system do, then it wouldn't really matter what time of the year we're looking at. The northern and southern hemispheres would receive about the same amount of light all year long, so our seasons probably wouldn't be as extreme. On the other hand, if we looked at the other extreme, where if we were extremely tilted, then one pole during its summer solstice would receive way more light, months and months of daylight, and the whole northern hemisphere would be lit, and most of the southern hemisphere would be in darkness during some parts of the year. And as the planet revolves around the sun, the reverse happens. So some planets like Uranus actually have this, and oftentimes that leads to more extreme weather conditions. Now, one last thing that you might remember is that equinox and solstices aren't always on the same dates. Sometimes they vary. Now, you might be wondering, why does that happen? Well, stay tuned for the next videos.